Hello, and welcome to the Aerospace Testing International podcast. In this episode, we speak to Jean Botti, Chief Executive of VoltAero, about the development of his hybrid electric aircraft.
Jean, can you describe your personal journey to the Cassio? From the days of the EFAN, how much of that project has carried over?
Yeah, my personal journey was molded by the long-held belief that aviation can be more environmentally friendly with the use of alternative source of propulsion. The work I performed that was performed under my direction at Airbus Group when I was Chief Technical Officer included everything from understanding and benchmarking of battery technology to the integration of the entire electric propulsion on aircraft. And that enabled me to fully appreciate the promises of electric aviation.
Mm-hmm. So at the time when you left Airbus, what year was it when you left Airbus?
Well, I left Airbus in 2016. Okay.
Mm-hmm. And
the hardest part when, for me to leave Airbus was to interrupt my focus on this electric aviation. And I decided to continue that today with VoltAero and our airplane Cassio, the one you see behind me. Mm-hmm. However, I'm particularly proud of what we have done in Airbus because we were able to have, as you remember, this historic flight, electric flight crossing the English Channel with the EFAN airplane. But before EFAN, the journey started in 2009 with the Cricri, which was a small airplane for acrobatics that we displayed both at Le Bourget and at ILA at the time.
Okay. Do you feel like you had taken the electric journey as far as you could at Airbus?
Not really. I wouldn't say that. I think that we could have pursued this Airbus journey, but at the time I left the company, decided to do something else. Mm-hmm. And when I saw that Airbus was stopping EFAN, I decided to come back. I thought it was we had to pursue this journey because for me that's the future.
Okay, so can you tell me a little bit about the early days of VoltAero and Cassio? Who was the driving force behind it, really?
Well, VoltAero is the direct continuation of my work, and it brings together many of those collaborations, the ones that work with me and electric aircraft project at Airbus. We're here some partners. It was a common idea of the three founders, but in particular Marina Evans, to bring together a team that we now have at VoltAero. We have an unmatched amount of hands-on electric aircraft experience. I mean, we accumulate more than 50 years of experience, today. The decision, for us to go by taking a demonstrator like the Skymaster, mm-hmm. That is an airplane that has become our flight test, completely changed, by the way. We just kept the airframe. Okay, because it was the only thing that was certifiable and it was difficult to recertify. We took the airframe, but if you look at the inside, it's completely changed. All the design is proprietary to VoltAero. We kept nothing really from EFAN. We just kept the experience of the evolution of the years and what we have learned, but everything inside Cassio is brand new to VoltAero.
Okay. Let's talk a little bit about testing. As we were talking earlier on, you're making some really rapid progress. And I know from the way that I've followed the industry, perhaps arguably you're one of the most furthest advanced in developing a hybrid hybrid electric aircraft. I mean, how much of the company's focus is on testing and certification? Could you give me a little bit about your approach to testing?
Yeah, in fact, there is a lot of time spent for testing and certification, okay? I would say that approximately 35% of our time is spent on that. And it will increase also going into the production Cassio. Specifically, so far we have been testing Cassio, the powertrains of Cassio for 4 seats or 6 seats, but now comes the most difficult one. It's the 10 seats. And the 10 seats has got a completely new hybrid propulsion module in the back, in the rear, and keeps the Safran engine in the front with the batteries in the front. But also we have added 3 power packs in the nose of the airplane. We took off the original engines of the airplane, replaced it with a Solution F engine in the back, and that makes a very complete new airplane. And that needed to have a lot of improvements and testing and validation, always hand-to-hand with the French DGAC, the Civil Aviation Airworthiness Authority, in order to get the permit to fly at every step. And we have been approved for 4 seats, we have been approved for equivalent 6 seats, and now we just got authorization for the 10 seats. But this is the ultimate, I would say, testing we're going to do with our demonstrator.
Okay. Can you just remind me quickly? I mean, what stage are you at with the testing at the moment, and when are you expecting to enter commercial operation with the aircraft?
Well, right now in the testing, we are like I said, at the 10-seat level, equivalent. It's the powertrain. Obviously, the plane is not the 10 seats because it's the Skymaster and it was only made for 6 seats. However, for this powertrain, we have done all the bench testing, all the functional testing, all simulations, and now we just have to fly. Okay, we're integrating right now all the power electronics, all the debugging of the electrical systems right now, and we will fly, in the next weeks. So that's where we stand at the moment. So, and this testing is going to continue for at least 1 year. This will be the base for developing the Cassio next generation, the production one, which is a total new airframe, but I would say the guts of the airplane will be very similar of what we have been developing for the last 3 years in VoltAero, the Cassio one.
Mm-hmm. Okay. So, I mean, obviously it's a different process compared to other aircraft, but what would you say is the most challenging aspect about the ground and the flight testing for Cassio, and how are the company's engineers dealing with those challenges?
Well, the most difficult thing for Cassio, I would say, and you pointed out before, is the certification, okay? Everything is challenging on Cassio, no question, okay? But I would say the most difficult is the validation certification of, even as an experimental right now, of the entire electrical electronic system for 10 seats powertrain. I mean, think about it. You got 5 electric motors, 1 thermal engine, and they all have to flawlessly integrate with each other by optimizing also the fuel economy. So you have always to have that in mind. So in this little aircraft, you got kilometers of cables, okay? Lots of controllers, sensor. In addition, you got a glass cockpit that looks like a cockpit for civil aviation airplane, because it's got multiple functions to control. So you need today 2 pilots to be able to fly our demonstrator. All this will get simplified for a production plane, and we're obviously learning a lot. But today, we got 2 test pilots that need to fly that plane.
And one is flying the plane, and the other one is doing what? Looking at the hybrid system.
Absolutely. One is focusing on the elements of the powertrain. The other one is focusing on the elements of aerodynamics, of behavior of the airplane, so everything that's got to do with the piloting of the plane.
So the control system for the powertrain, for the hybrid powertrain, I mean, when does it know to activate and deactivate? When does it know how much to play in the propulsion system? Is that something you're testing and developing now?
This is exactly what we're developing now for a production one. This is why I told you we're going to continue for one more year to do testing on this platform, because we're going to develop all the strategies and all the intelligence. And also, I don't know if you have noticed, recently we got into an agreement with Kineticair, with a company that does, mapping like Uber does for, cars. Yeah. Kineticair is doing the same for, for, I would say, aircrafts. So by working with them and being able to integrate this into our cockpit, we will be able to optimize each route, and find what is the best flight path, mission to get the maximum fuel economy into the plane. Can go from pure electric to full hybrid. Mm-hmm. And in the middle, obviously, there is mild hybrid. It depends on the speeds, it depends on the distance, and so it's there is no one size fits all. You have to integrate all this with intelligence. This is why we need to have a cognitive cockpit.
So I found that really interesting, the partnership with Kineticair. They've committed to purchasing the aircraft, first of all, which is great news for you. Is that correct? Is that right?
It's correct.
Yeah, but also from your point, obviously you get to sell the airplane, but also you're going to get data from that, which is going to feed into the operation, to the development of the aircraft itself. Is that right? My understanding of that.
It's correct, and at the same time, it's all benefit for Kineticair, because for them, they get to acquire tons of data that can improve, the way the software is working and the way it's optimizing, the routes and how they interface with the customers.
Mm-hmm. Mm-hmm. Okay, right. So you mentioned over the next year, the flight testing is really going to ramp up. What are the biggest milestones in that time? Is there anything that you worry about really, that you're really worried about?
No, honestly, at this point, I don't see any showstoppers. Uh-huh. I think we have gone full circle with Cassio. We just need now to keep flying it, acquire the necessary data, apply all the experience that we get from this demonstrator to the production plane. Mm-hmm. But I have to be honest, we struggled a lot for 3 years because, making a hybrid aircraft that's got 5 electric motors plus, 1 thermal one was not a small piece of cake. Specifically, when you look at the integration of all this, it's fully integrated, okay? It's not pieces that we put, no, we have fully integrated the airplane. We changed completely. Even look at the face of the plane right now, the aerodynamics are very different from the original SkyMaster. Yeah. And the next one is going to be one, a leap further. But we have not seen any showstoppers at this point that I can think of.
Okay. I'm just wondering, do you agree with my initial assessment that you're really breaking new ground with the aircraft? And this level of integration, is anyone else approaching that? What other projects do you think are coming close to you?
There is one for sure that I could think that is very, very much integrated, is aviation one, but it's a full electric. Yeah. It's not an hybrid. Mm-hmm. Okay. From what I've seen so far, this is probably the airplane that is the most integrated one as compared to ours. The same level if you want. But one big difference is it's a full electric. Mm-hmm. And for me, to be honest with you, I've been there before. I think that the hybrid is the way to go.
Okay, let's talk a little bit about that market and the way it's going to develop. Why do you believe that that's the way to hybrid is the way to go?
Because like it says, a hybrid means it can do electric, it can do thermal, it can do both. So you got the choice, okay, to decide, dependent of the route, how you're going to use your airplane. Mm-hmm. Second, you're going to have 2 sources of energy. Okay, if you make a pure electric, you're very dependent on safety, in terms of safety of the electrical system. In our case, if we have a problem with electric, we can always turn back to thermal. There is enough power there to drive you, to get you back home, to fly you home. If you have a problem with thermal, electric is also, so you got redundancies in there that allow you to really take safety at a very high level. I would say that we will get to the same levels of civil aviation today. And today, general aviation is not at the same level of civil. So that's a very important point. The other important point for us is that basically when we take off and we land, we're always an electric airplane. We're electric, no question. So the noise issues and everything, we are very much similar to any other electric plane. So I would say that based on the fact that the energy density of fuels, and when I mean fuels, I don't only mean avgas or stuff like that. I mean biofuels, I mean hydrogen, I mean many other sources different than what we have today. These fuels are orders of magnitude higher than what a pure battery system is. Okay, there's no question. It's from 3 to 5 times, even 10 times more, depending on the source of energy you have. So I think for aviation, this is the best transition to have. One day, when battery will have improved so much their power density, we will be able to switch back. But this is not the right time today for aviation.
Mm-hmm. So do you believe that the fossil fuels and biofuels still will have an important role to play in aviation, I don't know, the next 30 years, 25 years? Or?
Well, like I said, I cannot speculate today on the progress of batteries, okay? There is a lot of good work going on in the world. For sure, I don't see anything in the horizon before 15 years, then going beyond that, things move fast. We are in exponential technologies today. Things move very fast because a lot of people communicate. There is so we're in a world of increased exponential progress in technologies. So I don't want to speculate before 15 years, but for sure, there is nothing to expect before 15 years from now, except in the aviation like ours, in general aviation, where I think that's the right stepping stone, to help, to certify, to develop, and to progress into the civil aviation for later.
Okay. I think in your time you've been involved with the development of electric aircraft, the market has changed quite a lot, hasn't it? I mean, CFAN, we now talk a lot about urban air mobility and eVTOLs and the creation of whole new markets within cities and urban areas. Do you account for those things when you're developing Cassio? I mean, what do you think of those sections of the market? Will they impact on Cassio at all?
No. I mean, there is no doubt that electric aircraft will be a key element for future of aviation, no question. But my concern as a responsible executive and a true member of the aviation industry is over this early concept that are being presented by companies as reality, and which have real challenges to get to production. And what I'm worried about is that this kind of project, they raise unrealistic expectations, okay? And this can be damaging for all the more serious applications. That's what I'm, very worried about. It disturbs me when I see that, what I call air show magic, okay? A company presents a wooden mock-up that is unproven, untested design into an international event. And it announces double-digit orders for aircraft that doesn't exist yet, for which no valid performance figures have been demonstrated, no commitment to production has been made, and no firm delivery, that dates that exist. If you look at Airbus, where I was before, or Boeing, they would never make such promises for an early aircraft program. They would never do that. Mm-hmm. And I cannot see why an unproven startup company should do so. The only reason can be to attract money. But investors are smart. They want to see proof in the pudding. This is what we have always tried to do at VoltAero, okay? Meet every milestone that we have fixed ourselves without going overboard and, not taking care of what's happening around us. We're very happy about the fact that Pipistrel is certified an electric aircraft. That's a progression for everybody. But there are some guys that are very serious. There are some that are not. And the ones that are not may, hinder the progress for this overall new electric aviation. That's what I'm worried about.
Okay, I get the sense that you're very proud of the work that VoltAero is doing. Do you think it's important work for the aviation industry? The work that VoltAero is doing at the moment. How does it relate to your career in engineering? Is it part of the reason why you became an engineer to do this kind of work?
Sure. Yes. I always had two dreams in my life. One was to be an engineer and the other one to be a pilot. Mm-hmm. And thanks God, I had a chance to become both. So, men always dream to fly, and Leonardo da Vinci started to open the way, how to get there. And I think that we should all be proud of, this constructing flying machines, and, I see a lot of bashing right now, mm-hmm. But, men always wanted to fly and men always wanted to have freedom. Now we just need to keep pushing to make them quieter, safer, and with emission free. Okay. So that's my goal. That's what I want to do for the rest of my professional life. Mm-hmm. And I've considered that I've been privileged. And I've received plenty of recognition because of that. So the door is open for future young engineers. And quite frankly, yes, I am proud of the VoltAero work. I am proud of the guys that are part of VoltAero. But also, I want to extend it to the partners, to the people. VoltAero is a small microcosm into the biggest network of people that have been supporting us, helping us to go and to get where we are today. So, yes, I am proud.
So within an aircraft like VoltAero, there are hundreds, if not thousands, of small innovations that an engineer can put their name to. Is that something you'd agree with?
Absolutely. Yeah. And I think that we see guys like me, like Didier Sten, my partner, the one that flew over the channel. What we need to do is to be able to unleash, the creativity and support our young engineers, okay, to get to what their dreams, to what they want to get, trying to share our experience, but never try to block them, saying, "Oh, I've already seen that before. This is never going to work," and so on and so forth. Mm. I think that's something that you don't want to do as a leader. Okay, you need to let the guys, develop, constantly evolve, their ideas.
Okay, sure. So, hybrid electric aircraft. When do you think I will get on board one? And will it be a large airliner, or will it be a GA small regional airliner? What do you think will happen? Normal people like me.
First of all, for VoltAero, we look forward to welcome you on board in the Cassio airplane after the deliveries beginning in late 2022. So it's not that far away. No. Okay. Our Cassio will fly in ranges of 800 miles, so 1,400 kilometers, 200 knots cruise speed, which is 360 kilometers per hour. And with all the versions we have, 4, 6, 10, with very low takeoff distances, less than 1,800 feet, which is 550 meters. So we will be able to use this airplane in a lot of regional airports. So that answers your question. Is it going to be for civil aviation? No, I see that in the regional aviation, general aviation, but it's a necessary step. Specifically, when we think about what happened with COVID, not sure that people, will want to keep going, in regional distances, going into big airports. that are very crowded with all the risk and so on and so forth. I think that there is a new way of flying in my mind, using better small airports, that are underutilized. Take the UK, take Germany, take France. Most of them are totally underutilized. So I think there is a better way to fly, and still a very economical way to fly. And specifically for short distances, going from 200 to 600 kilometers. And you cover a lot of ground already when you think about that, because, this is a bird distance flight. It's not, like by car. So there's a lot of ground that can be covered.
Okay, great. That's all the questions I've got, Jean. I don't know if there's anything you want to add that perhaps we haven't covered. Do you think you'd like to communicate about the project, about the company?
The only thing I forgot to mention, maybe, Ben, is that obviously right now we're working a lot with French authorities at DGAC, but our intention is right now for the phase 2, which is the production aircraft, is to work directly now with EASA, okay, and FAA. And I forgot to mention that, but I think it's going to be a must for us, and we're starting right away. And
you see that as a step forward in the certification, obviously.
I do, and another thing that has been very beneficial for us, it's been that Pipistrel, the certification of the small aircraft, the Pipistrel it's very good, even if it's a small aircraft. Obviously, it's an LSA. But, it shows that the authorities right now are considering more and more this electric aviation.
Okay.
And today, realistically, if I had to put a bet, with the technologies we know for the short and medium term, we can go touch the megawatt, okay? That we can do. But going beyond that, it's a big challenge, big challenge. This is probably why today Airbus had decided to stop the EFAN-X, okay? Because there is a lot of complexity. Scaling up an aircraft like this, with technologies that, there is electromagnetic interference, electromagnetic compatibility, cooling systems, connectors, okay? Just think about passing thousands of watts and thousands of amps to make megawatts. It's a big, huge challenge, specifically when you want to fight gravity. Okay? The plane needs to be light. It cannot have, huge cables, huge connectors. We're not making a submarine. We're making a flying airplane. So going to up to 19 seats, I said yes, can make a very nice average. Going beyond that, there is a lot more work to be done.
So thank you, Jean, for your time. And thanks to you also, the listener. I hope you enjoyed that podcast and stay tuned for the next one in the series. Thank you. Bye-bye.